Good morning, students. Welcome to video lecture on Artificial Intelligence and Machine Learning with Python. Subject code U18EC502A. Topic Python code for support vector machine. Support vector machine algorithm. It is also called maximum margin classifier. Support vector machine or SVM. It is one of the most popular uh, supervised learning algorithms, which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. The goal of the SVM algorithm is to create the best fit line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. The best decision boundary is called hyperplane. SVM chooses the extreme points that can help in creating the hyperplane. These extreme points are called support vectors, and hence the algorithm is named as support vector machine. Support vectors consider uh, two types of data points. These are positive data points and these are negative data points. Here we need to apply support vector machine algorithm. For that, uh, margins are drawn. Uh, the margin with maximum marginal distance will be selected as hyperplane, and these extreme data points onto which the margin passes are called support vectors. In simple words, you can say uh, support vectors are the data points, or simply they are extreme data points. Extreme data points which are lying on margins of support vector machine. In case of 2D algorithm, sorry, in case of 2D data, uh, you can easily classify the data with the help of one-dimensional hyperplane. If it is one-dimensional, then it is called line. With the help of simple margin or line, we can separate the data which is present in two-dimensional plane. Means if the data is in two-dimensional plane, then you can simply apply a linear line, marginal line to separate the data points. Uh, if the data is in 3D plane, then here a 2D plane is required to separate the data, and that is why it is called hyperplane. Uh, here, if the plane is two-dimensional, then it is hyperplane. In case of 2D data, the separation can be done with the help of line. So this is not hyperplane. You can observe hyperplane in the figure how the data points are separated based on hyperplane. Margin. A margin is a separation gap between the two lines on the closest data points. It is calculated as the perpendicular distance from the line to the support vectors or the closest data points. In SVM, we can try to maximize this separation gap so that we get the maximum marginal distance. Here in the figure you can observe uh, different marginal distances are calculated, and the line with maximum marginal distance will be selected as the decision boundary. Here margin 3, it is having the maximum marginal distance, so uh, that margin can be considered to classify the data. Hyperplane. Uh, a hyperplane is a decision boundary which separates between given set of data points having different class labels. SVM classifier separates data points using a hyperplane with a maximum amount of margin. This hyperplane is known as maximum margin hyperplane, and the linear classifier defined is known as maximum margin classifier. It is another name of support vector machine. Refer to the diagram how the support vector machine classify the data with the help of hyperplane. Types of SVM algorithms generally classified into two types. The first is linear SVM. Linear SVM is used for linearly separable data, which means if a data can be classified into two classes by using a single straight line, then such a data is termed as linearly separable data, and the classifier used is called as linearly separable or linear SVM classifier. The other is nonlinear SVM. Here, the data is in nonlinear form, cannot be separated with the help of a straight line, and in this case, the used classifier is called nonlinear SVM classifier. Here you can observe uh, the data is linearly separable. The data points are mostly require linear machine learning classifier such as logistic regression algorithm is enough to classify the data. Here you can apply SVM also. Nonlinear SVM. Nonlinear separable data points are there. Then in this situation, we cannot apply linear SVM algorithm. Uh, the nonlinear SVM algorithm is used to classify the data. And here, the data points cannot be classified with the help of a single straight line and with a hyperplane. We cannot separate the data into two classes with the help of a straight line or with the help of a hyperplane. So here what we need to do is we need to apply SVM kernels uh, to increase the dimension of data. And here by increasing the dimension of data, the higher order data can be classified easily with the help of support vector machine algorithm. Now I explained SVM kernels. They are used to convert the lower dimensional data into higher dimensional data. If the data is in 2D, then this can be converted to 3D with the help of SVM kernels, and then apply SVM algorithm to classify the data. Once again, you can use the same concept, maximum marginal distance. Now here, it is a one-dimensional data. This cannot be classified by a single linear line. Just assume if it is x, then if we consider x equal to y equal to x square, by converting the data into the coordinates of xy, that is 1D data can be converted into 2D, and with the help of by projecting the data points onto the 2D plane, and with the help of a single margin line, the data can be separated. And the same thing can be applied for this data here. Uh, the data is not linear, it is overlapping data. Once again, you can apply the SVM kernel to the two-dimensional data to convert or to map the data into 3D plane, and then apply support vector machine with the help of hyperplane with maximum marginal distance. The data can be classified into different classes. Refer to one more example, conversion of 2D space into 3D space, and the classification with the help of hyperplane, that is the decision boundary between the two classes of data. Some standard SVM kernels are there. The first is polynomial kernel. Second, a radial basis function kernel. It is named as RBF kernel. Another type is sigmoid kernel. You can use the kernel as per your application and requirement. Refer to the formulas. Here, kernel with optimization parameter. As per your syllabus, you no need to go into the detailed mathematical uh, formulas or derivations. Just refer. SVM classifier, Python syntax. In the last class, we discussed about the Python code for logistic regression algorithm. In that, if you change the classifier, that is in place of logistic regression, if you import and define the support vector classifier, with the same code, you can classify the data easily. A minor change can be done in logistic regression, in that the supporting library and the supporting classifier can be modified to convert logistic regression algorithm into support vector machine. Both are classifiers. Python code, import library, load data. Here we have taken iris dataset. You can load data with the help of pandas also. Iris. If you are going to use pandas, then pd dot read underscore csv in single quotation iris dot csv. Here, if you are going to import data with the help of pandas, you need to upload the iris dataset, that is CSV file, into the files of Jupyter Notebook, then you can further proceed. Here you can print the target names and feature vectors, feature names of the dataset, setosa, versicolor, versinica. The column names are sepal length, sepal width, petal width, and the last is the type of specificities. Execute the code in order in different Python cells, Jupyter Notebook cells to get the output. Continue. Here, with the help of data 0:5 will print the top 5 data points. It is sepal length, sepal width, petal length, and petal width. Based on that, uh, what is the type of species it is? If it is setosa, then you can assign with 0 for Zinica. The target classification value is 1 versicolor. This can be 2. You can observe the target labels. Now here with the help of head command, you can display top 5 data points, sepal length, sepal width, petal length, petal width. These are the indexing values of top 5 data points. For the given parameter values, the algorithm will specify what is the type of species it is. Here, iris dataset, it is having 150 row elements. In that, first 50 row elements are related to setosa, and the remaining 51 to 100 virginica, and from 101 to 150 it is the data points are related to versicolor. Before writing the code, you should get command on the data set onto which what are the row elements, what are the column elements, for what data, what is the type of species it is, you should know. Then only it is easy for you to write the code, otherwise you will get some syntax error. Python code continue with the help of tail. It will display uh, the last 5 data elements. Here, as we know, the steps import library. Library import is already done. Load data is also done. Here, divide data into input and output variables. Here, with the help of the given syntax, you can divide the data into input and output variables, or you can use ilog method to divide the data into input and output variables. Then uh, split the data into training and testing sets. Here, uh, the syntax is x underscore train, x underscore test, y underscore train, y underscore test. It is equal to train underscore test underscore split input variable x comma output variable y. Test underscore size 0.3 means uh, the model is trained with 70%, tested with 30%. Random underscore state is equal to 0 means the data can be uh, splitted only once. If it is not equal to 0, for each iteration that the data will be splitted into training and testing sets. That is meaningless. So For all the iterations, if you want to maintain the same split, you can use random underscore state is equal to 0. Now here, uh, a small modification, with the help of the small modification, you can convert the logistic regression algorithm code into support vector machine. The logistic regression algorithm Python code we already discussed in the last class. You simply change the classifier. By changing it, you can predict the output with the help of SVC. Here for SVC, what are the modifications? Here the modification is import the associated library from sklearn.svm, import SVC. Here the SVM classifier is assigned to the variable CLF, means here we created some we created a SVM classifier with the name CLF, and after splitting the data, train the model with fit function. Follow the syntax, train the model, and the last step is prediction. Uh, Prediction can be done with the help of the input testing variable. You can specify the prediction variable name as per your requirement. Here I specified y underscore PRED. And the next is from sklearn.matrix. It is used to calculate. This library is used to calculate the accuracy of the model. Follow the syntax. It will print the accuracy of the model. The accuracy of the model is almost 97.7%. It is directly displayed with the help of matrix function which is available in sklearn library. The next is prediction for sepal length 3, sepal width, sorry, for sepal length 5, sepal width 3, petal length 1, petal width 0.2. What is the type of species? It is setosa. Like that, you can determine, you can predict the output, either it is setosa or versicolor or virginica. Thank you. We will meet with the next lecture.